This lesson is for FST 4-7 on stretching and shrinking with cosine and sine. When we first did stretching and shrinking, that was back in lesson 3-5, and they were called scale changes. Remember, if the scale changes that you're using for A and for B are the same, then we call it a size change. So these first pieces of the lesson today are literally taken from lesson 3-5 when we did that lesson the first time. So a reminder that capital S is our scale change rule, and usually you'll have your pre-image listed first and then your image listed after the colon or the equal sign. The A value is usually paired up with the X or the independent variable. The B value is usually paired with the Y variable or the dependent variable. When in the rule you are multiplying by A, that means it's going to stretch by A. If you're dividing by A, that usually means it's going to shrink. The other way that you can tell the difference between stretch and shrink is if the A value is greater than 1 or less than 1. So if you multiply by a half, that would be the same as dividing by 2, so that's going to shrink. Similarly for the B value is multiplying by the Y, so that's going to stretch or shrink vertically. A B value greater than 1, or with multiplication, you're going to be getting a stretch. If you divide by a number or multiply by a fraction, it's going to shrink. Remember that when you're applying that rule to coordinates and graphs, you can just look at what the rule says and know that it's either going to stretch or shrink based on what you see. However, when you apply the scale change rule to an equation, you do the opposite. All we're going to do in this lesson is modify what our function looks like. Basically, all we're going to do differently here is, instead of it being a function like x squared or x to some other power or square root of x, the only difference here is we're just going to do the sine or the cosine or the tan of x. So just a quick reminder here, if this is your rule and you're multiplying by a in the rule, multiplying by b in the rule, then when you apply it to the function or the equation, you will be doing division. So let's apply this to some examples here for sine and cosine. Note that I chose sine in my original notes here, but that could have been a cosine as well. So they want us to find the equation for the image. They're telling us to use sine as our parent function, and they're giving us the transformation of xy turning into 5xy. They purposely don't tell you which transformation you're doing here. You have to recognize that because you're doing multiplication, that is a scale change. In the rule, we're multiplying the x by 5, so when we apply it to the equation itself, we want to do the opposite, or the inverse operation. So we would be doing x divided by 5 here. The y value is remaining unchanged, so we can just leave the y as it is. So that one's not very exciting. Let's try one that's a little bit more challenging. This time they want us to identify the rule, and this is the image equation. Right away you can tell that the x is being doubled, so if we talk about the rule that's happening here, we know that if we're multiplying by 2 in the equation, that means we're either going to be multiplying by a half or dividing by 2 in the rule. The 3 here is not quite as clear. Normally the 3 would be over here with the y, so I'm going to solve this equation so that the y is not alone anymore. If I did that, that would mean I'd have to divide both sides by 3. So now I get y divided by 3 equals sine 2x. So clearly you can see here that in the equation, the y value is being divided by 3. So that means in the rule we would have been multiplying by 3. So the rule is a half x and 3y. Could also say x divided by 2, 3y. Multiplying by a half and dividing by 2 are indeed the same thing. So know that you could have the rule in either fashion. Next, I'd like to look at some real-life applications because there are some implications for doing a scale change on a sine or a cosine graph. The real-life application here is that sine waves look like sound waves. And when you do a scale change on a sound wave, we can measure what the effects are. We need to do a quick review on the period. Remember that the period is the length of one cycle of the graph. And so typically, if we're looking with just cosine or sine, the period is usually 2 pi. So if we take the a value from the rule, so let's go back here, if we're working with an a value from the rule, that's going to lengthen or shorten what the period is going to be. So that a value, regardless of it being positive or negative. That's why it's got the absolute value symbol. If you multiply the period by a, that'll tell you what the new period will be after it's been scale changed. We need to know the period in order to answer two real-life applications of how the sound or the sine wave is affected. The frequency, which represents the pitch, those of you who are musicians would know that when you're looking at different musical notes, they have different sounds. So a C note, for example, on the piano, there's a middle C. That has a different pitch from the notes right next to it, like D. So the frequency is a measurement of what the pitch is, distinguishing one sound from another. And in the problems that we're doing, the frequency is the reciprocal of the period. So usually I tell kids, figure out the period first and then just flip it over to find what the frequency is. Another important piece about frequency is that when you double it, meaning this value here, if you double it, that will change the pitch one octave higher. And again, that's just information for those of you musicians to kind of help you give some context to what the frequency is all about. So doubling the frequency gives you a one octave higher sound. So if you were at middle C, if you double the frequency, now you're at the next C up on the scale. Another thing to keep in mind for frequency is that it's usually measured in hertz. A lot of times the hertz will be abbreviated as just Hz. So if you see that, that's what that's referring to. So that's a way that you can tell if they're referring to frequency or not in a problem. Another application for sound waves is the amplitude of the sound. The amplitude is half the distance between the min and the max. So if you think about the wave shape and the look of it, if you go to the top of the mountain and the lowest valley and look at how far it spans, cut that number in half and that'll be your amplitude. It's also a really easy number to find if you have your rule. The absolute value of the B value in the rule represents the amplitude. If you're trying to remember or recall what amplitude is referring to as it comes to sound waves, the amplitude is a measurement of the volume or the intensity. The book will usually refer to the amplitude as intensity, but for most students, when I tell them that intensity means volume, then they have an understanding of what that means. So it's talking about how loud it is. If you think about too a sine wave and how it looks and how that relates to a sound wave when you picture it, the higher the peaks and valleys are, the louder the sound would be. Keep in mind that when you're plugging in A and B into these values for frequency, amplitude, and period, we're using those values from the rule, not from the equation. So let's apply this to a few problems from the homework. So I think these are questions 2, 3, and 4 from your assignment, so we're going to kind of do those together right now. So in number 2, they give you this equation and they ask you for the amplitude and the period. I would highly recommend that you write the rule before you do or tackle the amplitude or the period. That's how I always do these. That's how you'll see me demonstrate all of these types of questions. So as I look at this example or this equation, the x has nothing happening to it, so I'm not going to write anything for x in my rule. The 3 should really be brought over so that it's with the y. If I bring it over, it would be division. So if I'm dividing in the equation, that means I'm multiplying in the rule. Because remember, the rule and the equation have to be inverse operations of each other. So that means my a value is a 1 and my b value is a 3. So I'm just going to quickly write that just so I have it as kind of a visual reference. So if a is 1, remember that that's going to affect the period. The period should be 2 pi times whatever the a is. So in this case, it has not been stretched or shrunk horizontally at all, so the period should be unaffected. 2 pi times a is what we get for the period, so the period is indeed going to remain at 2 pi. The amplitude, remember, is just the absolute value of the b. So in this case, the absolute value of 3 is still going to be 3. Let's try another one. Number 3 right below that is y divided by 4 equals cosine of x over 3. In the equation, both the x and the y are being divided. So if I write the rule, even though they don't ask me for it, writing the rule is probably a good idea here. So if I'm dividing in the equation, I know in the rule I'm going to be multiplying. So that means the x is being multiplied by 3 and the y is being multiplied by 4. So remember, when I find the amplitude is representative of the b value, The b value is the one that's with the y. So the amplitude here is going to be the absolute value of 4, which is 4. The period is going to be 2 pi times whatever the a value is. The a value is 3, so the new period is going to be 6 pi. Let's go over here to question number 4. This time they give us a picture of a scale-changed graph, and we're going to need to determine if it's sine or cosine. And then if we're dealing with a 3 and a 2 and where those numbers are going to go. So this is a really good illustration of how the amplitude is affected. You can see here that the top of the mountain goes up to 3, the bottom of the valley goes down to -3, so that's a total span of 6. The amplitude, remember, is going to be half of the total height from top to bottom. So the amplitude here ends up being a 3. All the equations have a 3, so that doesn't really help us in our quest for finding which one of these 4 is the equation. It's really important for students to think about amplitude correctly. Later on in the lesson or later on in the chapter, we will be doing amplitude for translations, and it's really important that students don't just think that the top of the mountain is what the amplitude is. When this graph has been translated, the top of that mountain won't necessarily be at 3 any longer. So it's really important that you remember what the amplitude is. It's half the distance from the top to the bottom. So in this case, the top to the bottom spans 6, halfway between would be a 3. Again, that doesn't help us because 3 is already in all of our choices. So the next thing I guess we should consider is whether or not it's cosine or sine. A quick review of the the cosine graph. Reminder that that starts up high and then dips down and then comes back up. So I'm guessing it's probably not A or D because those are both sine equations. So then my only other piece that I have to worry about is where that 2 should go. Now if you think about what the 2 does, or what that a value is going to do, in the rule that a value will multiply by 2 pi. So let's look at how long this graph is taking to complete its full cycle. It's crossing at 180 and then at 540, and it completes its cycle right here. So we have to determine what that value is. So halfway between 540 and 900 we should subtract and then divide by 2, and that'll tell us what that value is. So I believe that number is at 720. And so if you think about the graph starting at 1, traveling 720 degrees, that means the period has been doubled. It's taken the graph twice as long to complete one cycle. So we want the a value to be a 2. In the rule, the a value will be a 2 times the x. So when we apply it to the equation now, that should be division. So that means that C is the only choice that's accurate here for this graph. I know that that's a little bit confusing, so I'm going to go ahead and write that out for you. So the period got doubled. And remember that the period is 2 pi times a. And I want that period to be 720. Or if we did it in radians, 4 pi. So in order for this to turn into a 4 pi, my a needs to be a 2. Remember that that a value comes from the rule. So if I write my rule, I know that in the rule it would be 2 times x. So when I apply that now to the equation, it has to be division, or the inverse operation. So that's why I chose C. Lastly, I'd like to go back and look at one more of the questions that we've already done and talk about its graph. One of the things that students will eventually need to be able to do is graph. So let's go back and revisit this example that we did earlier of 3 sine 2x. So if you look at the rule that we wrote, either one, we can see here that the a is a half, or divided by 2, which would be the same thing, and the b is a 3. So let's think about those two values now in terms of the amplitude and the frequency. Amplitude and period. So the a value, remember, is affecting the period. So if we are going to figure out the period of this graph, it's going to take half as much time for it to complete its full cycle. Mathematically, what we would say is that it's 2 pi times a. The a is a half. 2 times a half ends up being pi. So this graph or this equation is going to complete its cycle much faster than normal, or in half the amount of time that it normally would. The amplitude is going to be 3, which tells you half of the distance from the top to the bottom. So if we were going to make a quick sketch of what this graph would look like, we know it's a sine graph, and remember that the sine graph usually does that for its shape. And for you to make an accurate sketch, we would just need to label that it completes its cycle by the time it reaches pi, and the top to the bottom here is going to be from 3 to -3. So all we did was graph what we normally do for sine, but we just modified the labels to make it match with what we know is happening in that situation. I want to try that question just one more time, just giving you another mental picture of what we just did with that problem. Remember that the period was 2 pi times a half, so the period was just pi, and the amplitude was 3. So if we just graph a regular sine graph, and I use my grid lines here to kind of help me be accurate, normally we would go up to 1, cross at 180, down, and back up. So normally my sine graph would look like this. Now I want it to go up to 3, and I want it to complete its cycle by the time I get to here, or halfway. So if I count up 1, 2, 3, and I don't want to go to the first one, I want to go halfway. And then back down, 1, 2, 3, back down halfway, and then completing it by the time we get to the 180. So the new scale changed equation actually is going to look like this. So you can see that the original graph is the purple, and the new one has been stretched and shrunk, stretched vertically and shrunk horizontally. It's completed its wave in half the time, and the amplitude has been modified so that it goes up to 3 and down to -3. Students should be fairly comfortable with this type of idea for their graphing. I would highly recommend that students use graph paper when they do these types of graphs. And then always make sure you label, either in degrees or radians, and make sure you're labeling the y-axis as well.